Hi everyone, today I'm going to show you how to read files from 3 different directories, and we'll compare if these files are similar. Means we'll compare based on their file names, and if we have same name then they will compare the data. Either this data could be a time series or any kind of data. So because of this purpose, for validating any model result with the observation, we need to compare, right? And we need to plot. So today in this tutorial we'll see that we'll look through 3 different directories and we'll even check if we have the same data point, means if we have the data for the same stations or for the same locations as well. So how can we do that? We have to write specific command for doing that, and I think these are very necessary for doing research and for model comparison or for model validation or calibration. We need that. We need to plot this type of comparison. So let's see. So I'll do that, a comparison plot, and looping through each of these directories. We can do that in Linux machine. We can do that in Windows using either Spider editor or even the Jupyter notebook. So I'll show you first using Spider today. So if we open, let me just share my screen, and that will be easy first. So if you just open, right, if you install Anaconda, so that means you already have your Jupyter notebook, you have your Spider editor. So some people they are basically interested in writing code in Spider. So that is the Spider interface, right? You are familiar with that one. So I'm using Python 3. So the version you can see, Python 3.9.4. so that's the latest one I have when I'm just recording this video. And we will have variables and plots, everything there, and that is the command, and that is the editor here. So we'll write our code here and we'll see everything there, and if we have any plot it will display there, okay, and the variables as well. So what I'm gonna do, let me just show you the data set. I have data set, right? These are the hourly data set. These are the files. I have 100 files here, and inside that file what I have time. These are the time series data. So I have time, and I have the water level, I have the tidal level, I have atmospheric pressure in terms of inch of mercury, right? The pressure is this one. So we'll plot and we'll see. So we have this data. These are the sensor data, and I converted this data as hourly data. So I have another data from H-warp model. So there. So I have the same file names, but because of that file size, this will be in a different order. So if you just loop through each of these files, so the first file may not be this first file from this directory. It may be different one, but we have to compare the same files because these names are the station names, right? So then how can I do that? So these are the same. We have the wind and pressure from H-warp model output. So we have the pressure. First column, right? The first column is the index column, time index. We'll use that as time index, and we have the X component of wind and Y component of wind. But this time we'll only plot the pressure. Okay. And I also have another directory where these are the Holland model output, wind speed and pressure, the same variables we have from the Holland model. Let me just close that Holland model, and I have the same 100 files you can see, and I have the wind speed and pressure. So each file has different pressure values, right, are located in different columns. So that doesn't matter, but we have the file name and we have different even length of the data set. That doesn't matter even. So what will matter, we have to check, right? We have to loop through 3 different directories, each of these directories, and we'll list all of these files, and then we'll check if the file names from each of these directories are same. Then we'll read each of these CSV files, and then based on that information we'll even plot all together, and we'll see the comparison plot, how it looks like. Okay, so let me just try to import some of our module. As usual, we have to import operating system, and we have to import system as well. OS and SYS, you can import that. We need to import pandas because we'll read that CSV file, right? So import pandas as PD. We can import pandas as PD. Then you need to even import NumPy, or that is not necessary, but we'll import even all from pandas. Okay, so from pandas we can import even all. This is how we can import. If you star, it will import all of this. Okay, so that will be as, that's what is showing that command. And what we need to even import date time, because we'll deal with that date time. Okay, so import date time, or yeah, or from date time we can import date time, or we can even import date time altogether. That's okay, no problem. And then what we need to import, because for listing any directories, if you want to list the entire directory including the backslash or forward slash, including the file name, you have to import globe. If you don't have that globe installed, so you have to install using that command, right? So this command pip install, because, and then globe glob. If you hit enter, then it will start installing that module, right? So we are just importing that globe, right? So this is how we can import everything. And if you want to plot, so we need to even import that matplotlib. So you can import matplotlib.pyplot as plt. So we're going to import matplotlib, right, .pyplot as plt. So if we call plt, that means it will just call pyplot from matplotlib. So that's it. Okay, and then we need to even list the directories. We can copy 3 different directories we have here. We know already that, right? So that one is the observation, so we can copy the first one, the first directory we have, and then I'm putting it here. So that will be the usgs. Okay, so that will be our usgs. So that directory will go inside our this. Okay, so I'm just listing that way. I'm using forward slash, so that will exclude the R. We don't need that R, so that's why it's this. Okay, so we have that usgs, and then we can even write hwarp, right? You can use hwarp, and you can go to that file as well, hwarp file. So here we have hwarp. Even you can copy the entire directory and you can paste it here, and even you can use the same forward slash as before, right? You can use the forward slash, that one. And you have Holland, right? In terms of Holland, it is parametric model. I'm using that param command, and I'm gonna copy the directory. So I'm just locating, okay, I have 3 different directories by 3 different name. Okay, and then I'll list all these directories, and I'll even compare, because these are 3 different directories. The full directory is different. That's why what we have to compare, we have to compare the file names only from each of these directories. So that is the command. So what I'm gonna do, I'm gonna specify, right, the output directory, because if I want to save the plots, so that is the output directory. We can even, okay, specify that, okay, I'm specifying the main path as my download directory, and inside that download directory I'm specifying, right, plot, pressure validation plot, and in between Holland model, hwarp, and usgs, and I can even change the date, right, today's date. Then it will create, it will check if we have this file inside my download directory. If it is already there, then it won't create any file. If it is not there, then it will create a file by this name. That is the if os.path, and if it exists, the out directory, then it will check. Otherwise, if not, that's what it's checking. If not, then it will create. Otherwise, it won't create anything. So that is the command. I'm creating the output directory as well. And now it's time to use our command. So that is the command I can even use here. I'm quickly showing. Okay, here. So I'm specifying usgs location, and I'm just using that os.path.join and usgs. I'm just joining basically the entire directory and the usgs, right? I'm joining and star.csv. So it will only list or join everything that has that .csv extension. That's why we're using that. Whatever the name in front of .csv, it will list everything by this extension. And same for others, okay? AceWarp location and param location. And from that listing, I'm even using that globe command, globe.globe, and this location. Then I'll have a list. Let me just run this code up to this one so that you will understand what I have, okay? If I just save the, I'm saving it to the same directory as comparison plot, okay? Comparison plot, and that will be the Python file, okay? It will be Python file .py. If I run it, hitting that button, see we have that because I used that print command, created the list of that files, every file. So I have. If I see the variables, I have all these variables here. And if I want to see the list, okay, what I have here, usgs file name. So if I just copy and paste the variable name I'm calling, I have all this list. See, it is showing the entire list for this file, listing and specifying that file name. It listed everything, and same for other files as well. So same for other files. So now what we have to do, basically we have to, okay, here. Now we have to compare. So we have the same list. We have 3 different lists, and now we'll loop through each of this list. But we're not sure that, okay, this lister, because it is a list of files, right? We're not sure that, okay, this lister, like in a ascending order, descending order, it created the way files are there. It may not list the files in a way that is already there, right? It may be based on the file size, it may be based on the date, everything. But since the names are same, if we just sort all of these files, then it will be easy to loop through, right? And then it will loop through the similar file at the same time. So that's why what I'm gonna do now, I'm just gonna use a specific command, right? So I'm looping through a list altogether. So what is the command for looping through different lists? We have to zip them together. So that is the zip command, right? Since I have 3 different files, list of files basically, or 3 different variables, but these are the list. It may be list of numbers, list of any string, anything. But in this case, we have a list of string. Basically, these are the string, means text, okay? So here, the first variable I'm giving observed, then we have simulated AceWarp, then we have simulated parametric, and I'm zipping, right, every list of files. I'm zipping. First one is observed, so usgs file names, and I'm sorting. If you use sorted command, so it will sort, right? Based on their A, B, C, D, it will sort. And then same, because I have the same file name, so it will sort, and all list will be similar now. Because these are the, not the values, these are the file names and the directories, including everything. This list, it is the long directory list. Now I have everything. So now I have to check if the first file, because it is looping, for loop, right? It will go through the list one by one. So it will go through the first value or first name, for example, the first name of this files. So that one. And it will, for example, we have this list. And then we have the comma, right? Then it will go through the next string. So it will just loop through each of these 3. And now we have to check if these are same. But before that, these are not same, because see, these directories, these are not same because they have different final name. File names are same, but these names are different. That's why we have to exclude the previous directory name up to this one. Okay, up to this one we have to remove those part. We'll only consider the file names, main file names. So how can I do that? We have to use, and we have to split as before. I'm just splitting 3 different file names. Okay, and then I'll print. Let me just show you if these are same. I'm quickly, because I have written these files. So there I have the long list like this one. Can you see here? Okay, and from the observation I use the same command that I just demonstrated in the previous tutorial, in renaming tutorial. So I'm using the same command, was.path.split text and observe. Then what it will do, it will split everything up to the extension .csv. So even it will include the backslash, it will see, it will include all this part up to CSV. So if I run, okay, let me just quickly run that, and I'm gonna show you that. So what it is giving us. Okay, see, it will give us, okay, so I'm just running. See, it is reading and it is giving us this, but it is not giving us any .csv. See, the last one, it is giving us everything other than .csv. It is not giving us that, right? And now what we need to do, we have to extract only the last part, excluding the CSV part. So how can I do that? So that's why I'm using another command here. I'm just splitting again based on that /, because I only have the /. If you have /, you can use /, and from that slash I'm only extracting the last part. When it will split, it will be splitted this way. It will be splitting based on that slash. So I'm not taking other part, I'm taking the last one by index. So what is the command for extracting the last value? The index is -1. If you have 0, 1, 2, 3, it will count from the beginning, but if you use -1, that means it is specifying the index of the last value. So I need the index of the last one, so it will specify this part, the file name, right? The last part of the file name, this part. So now I'm doing the same thing for every file, and now if I print, then I'll have only this part. Okay, see, I'm printing that and I'm running. I have that part. Can you see that? Observed name, param name, and it is giving us this one. So okay, so now what I have to do, I have to compare. Okay, I have to compare the same name. Okay, I'm just checking here if it is there. See, I have up to this one. I have up to this one, so it should, let me check if everything is okay, otherwise it will be difficult to even follow. We're printing everything. Okay, and now I have to check if these file names are same or not. Okay, now I'm gonna check if these file names are similar or not. If these are similar, then read the files. If these are not similar, so don't read, just show me some error message. So I'll write what message I need. So that's why I need to use another if command. So I'm using if command and I'm checking this. Okay, if these are same, here another command, if command, if that file name means this observed name or any part of the file name, this one, this file name is same as the file name from HWorp, this file name, and if the observed file name again same with the param name, this part. That's why I'm extracting separately and preparing the string of the main file name, and I'm checking using if command if these are same, right? This equal to this one and that equal to this one, then we can read. So that is the command, and before that I'm preparing a new name and title of the plot. So since I wanna save, I'm giving the preparing a new name as before. So new name will be the observed name or any name like this one, and then the extension will be PNG if it is the name of your PNG file, means your graph or your image that you are gonna create, right? And that is the figure name. And if you want to save the combined files, right, then you can use the extension CSV. You can do that. I'm not gonna do that, so I'm omitting that one. So I'll only plot and I'll save only the PNG file in my output directory there in the plot file. So that's why I'm keeping .png, and I'm using that title for each of this file name by this file name. Comparison of observed and simulated pressure at that file name. If it is this one, it will be that. If it is the next, it will replace the station name. So every title will be different. This part will be same, but the last part will be different. Okay. So once we have that, we are gonna read each of these files, because we have the name. USGS will specify the first name of USGS list, and then sim aswarp will be assigned. It will assign the first file, right? And if these are same, then we'll only read each of these files. So what is the read command? If you wanna read CSV file using Python, you need to use pandas. Okay, so we are calling pandas as PD, so we'll use that command. I'm gonna quickly show how to read. And here is the command. Okay, so at first I'm reading that aswarp, and since it is a data frame, so data frame and simulated aswarp, and I'm reading PD dot read underscore CSV, and I'm giving that variable name here, that variable name. It is the full path. It is the full path of the file where the file is located, including the extension, right? .csv. And since the first column you already saw, right? First column, I'm using that date time column. If you know the header name, you can pass that date time, or I don't need to know the name. I'm assigning, okay, the first column, you should assign the first column as index, right? Since it is date time, it will be date time index automatically, and I'm parsing the date. So that is a specifying, okay, the first column, the index column is date time column, so it will be looking like a date time. And if there is any missing value in between, there must be some value. So I'm just filling that value, the none value or the null value, whatever we have. If it is none, it is empty, it will show none. So whatever it is, so it will fill that NA value, null value or the none value. By what? I'm using that forward filling, ffill. Even you can use any mean value of the column anyway. You can use any specific value, 0, or you can assign anything there. The method I'm using, if I have any missing value, right, any gap, for example, there, if I show you that way, first one, see, I have the missing value here. So other than if I have missing value for pressure, this one, it is missing. So I'm assigning, okay, fill this value by this previous one. That's why it is called forward filling. If you want to fill this value by this one, you have to use backward filling, B filling. So I'm using forward filling, right? So that is logical as well. So it won't be, because these are the hourly time step. So if you have a pressure value, and if you have missing pressure value, and if you have value for now, and if you want to replace the missing value for the next hour, you can, it is logical to use this hour or the hour after next. Okay, it is logical. So that's why I'm using forward filling. But if you have a lot of missing values, then it will be problematic. You don't need to replace those. You have to treat your data set, right? And similarly, I'm reading other parametric, and also I'm reading the observation. So now I have everything, and it will, if I run, it will even read, and it will plot each of this data frame. So that is the condition we have. Okay, so that is the logic behind this one. And if you want to plot you have to you already called that .plt, right? We already have that. We already have .plt, so we can do that. And now what we need to basically copy and paste here another code. I already have that for plotting. So this is how we can loop through each of this column, each of this file list. And if you have any different directory that, okay, I have a list and I have another directory, I have different list. So at first you have to use globe command to list all of these files, and then you have to check the list if these are the same files or if there is any matching. If they're matching, then you are reading each of these files and you can plot. So now the next step is to plot. Okay, I'm gonna just plot. So I have the specific command, I can use that, and I'll show you everything in the Linux machine as well. So now I'm gonna specify the subplot and the figure size. That is kind of A4 paper size, right? 11.69 and 8.27 inch or centimeter. These are the inch. Okay, and I'm just specifying grid. It will show you the grid, and the grid will be like dot. And then what I'm doing here, that I don't need this part, it will be okay. And here I'm plotting because I'm specifying the index, each of the index of each of these files, and I'm also specifying the column, right? So by the column name, you can call any data frame or any column from a data frame using the column name. So here I'm specifying the same thing, right? I'm just generalizing for the third value from the observation data, it is the pressure value. So that's why the index is 2, because if you use the date time column as index, then it will be gone. So you have to use the next column as 0 index, column index, and the second one will be 1, the third one will be 2. So in the third column, actually we have the pressure value, right? So we are using that as 2, and I'm using the marker as like dot, and it is O, and color will be black, and the line style will be none, and marker size will be 2. I'm specifying the property of this, and what will happen for other plots, right? So for simulation HWARP, I'm using even all index, same thing, calling the index versus, because the index will be along the x-axis, this will be the date time column, and along y-axis there will be the pressure value, right? And I'm converting here, since the observation is in centimeter of inch of mercury, so I'm converting the Pascal into that mercury, right? So that is the conversion factor, and I'm using the color as blue, line width is 2. And for Holland model, the parametric model, right, it has a long date, so I'm trying to match only the depression part. That's why I know these are the index from where 235 I'm reading from that specific. I can show you quickly if it is parametric. Okay, if that is the parametric, the index is 235. So I have this 30th August 2018 and 12 hour. I considered that, okay, I'm gonna even plot right from 9th of September 2018 and from 6 hour. Since the index the value of this is 236, in Python it is 0 based index, right? 0 based. So it started from 1. When it is 1, it is gone. This is the header. So that will be 0, that will be 1, right? So it is starting from this one. So we have to even minus 2. So 236 minus 2, it will be 234, right? So that's why I'm using that, or 235. You can use anything. Since it is starting from 1, I'm just deducing only 1. So it is 235. And similarly here, but this time these values are not in Pascal, it is in HPA, right? So we have to multiply this by 100. So that's why I'm just multiplying by 100 to convert it to Pascal, and then I'm using the same factor to convert it to inch of mercury. And then I'm just using okay, the legend, the first one is the sensor pressure, second one is the HOR pressure, third one is the Holland pressure, and the column will be 1. These are the legend, and the location will be best. It will find the best place automatically. It will find the empty place and it will place there, and the font size will be 16, and the X level will be time zone, it is US or Eastern, and then the Y level will be barometric pressure, right, in inches of mercury. And then the tick parameters, these are like this way, and everything will be bold. So these are the general command. You can find it from that matplotlib, right, from manuals or website. These are the property you can just quickly add. That's pretty simple. That is not that. It will be based on your aesthetic value and your test. It is nothing. And then what I'm using, this is the most important command, I think, fig.tight layout. So if you have any remaining space, so it will just cover your entire plot, so that will look good, right? So that is this. And then what I'll do, because I'm looping through each of these files and I'm reading them together and I'm plotting one by one, right? So that's why I'm asking the code, okay, show me the code and automatically close it and pause for 2 seconds. So it will display the image for 2 seconds, and then it will loop through again to right, and it will read the second file. It will compare if they're equal and the same file, then they'll read it again and they'll plot, and then it will show you the plot for 2 seconds, and then it will do the same thing over and over and until it's done. Since we have 100 file, it will loop through 100 times and it will show you that. You can even specify that even 1 second, 5 seconds, 3 seconds, any. So 2 seconds is enough. If you can look at that, right, the plot, you can look at, okay, this is the plot, I can do this, okay? So, and then I'm saving, and then it will close, plt.close. After displaying for 2 seconds, it will close automatically, so you don't have to do anything. And then it will save to this directory, because I have already specified the name. The name will be based on the file name, the first part of the file, excluding the extension, and then it will add .png file. So the file format will be png, and I'm using fig.savefig. That is the command for from matplotlib, and it is joining the directory, output directory, right? I specified the output directory already, and I specified the name. If the name is already there, it won't create any folder name, otherwise it will create, and then it will create that resolution. DPI is 300. You can increase that. It will increase your resolution and file size as well. So that is the complete package. That is the complete package, right? That is not that hard. It is pretty simple from my understanding. And if you can do, yeah, if you do this, it is pretty easy, okay? It is not that hard that, okay, it is not rocket science. It is pretty simple. Anyone can do that, okay? So I'm gonna show you everything, because I'm not gonna plot here. It will kill our space and it is not convenient. So I have the same code written in my Linux machine, and I'm gonna run it, and you'll see that is the code you can see, okay? So that is the code that is for Linux machine, and I'll run it, and you'll see the graphs and you'll see the plots, everything, you'll see that, okay? And for that, if I run it, I have to share another screen so that we can see the plots, okay? So I'm gonna log into my Linux machine. It is already there, okay? And I have all these files. You can see the directory. These are specifying as hourly pressure sensor, and these are that. So these are the files I can show you, right? So that are the USGS pressure hourly. So these are the files I have. And then I have the Holland, okay? I have the Holland one. These are the Holland file. 100 file is there, out there. Then I have also HOR files. So I have the same files, okay? So you can run the same code. That's why I'm showing everything. You can even, when you write code, you can test the code piece by piece using either Jupyter Notebook or even using that Spider editor. So once your code is ready, then you can even use your Linux machine, or you can even try here. We have another editor to do that, okay? So I'm just using that command, Python, and that code. the name of the file. Okay, it will be del 3D Holland and atmospheric pressure. So I'm gonna switch to the other screen so that you can see the output. Okay, you can see the output at the same time. Okay, I can run here, then you will see it is reading and showing, and then I can quickly see it is reading all these files, and it is printing and already displaying the images there. So I'm gonna show you that. Okay, I'm gonna share other screen so that you can see what they are plotting. Okay, see, they're plotting these images and it is automatically closing. So that is the beauty of programming. If you know programming, so your life will be easy. Otherwise, what we had to do, you had to even copy each of these files, right? The values you have to open by clicking, and then what we had to do, you have to copy and make all these files in a single column, right? And then you can even go to insert, and then using your Excel, and then you have to plot manually, and you have to assign, and you have to change the X and the font and the size and color every time. You have to change everything. But once you have the code ready, and if you run it, so it is doing the job, right? Doing the same thing for 100 times, and even if you have 1,000 files, it will do the same thing. So that is pretty simple, and you can reproduce everything. If you have any problem, you need to change your data, so you can even change your data and then run the code. It will do the same job. You don't have to do everything every time, right? So that's why you need to know all this processing. If you have even 4 directory, 5 directory, if you want to compare, right, and plot and read everything. So that is the step. I'm gonna stop here, and then you can try by yourself. Okay, then if you let me know how can I improve, and if I need to even show you something else, because I'm not going to show you the basics of for loop, because there are a lot of tutorials that will show you and you may have idea about everything, but I'm just implementing that programming knowledge here in your practical right, in research or in practical life. So that's the application. So you'll find very less directions and tutorials out there, because I was facing a lot of problem on this one. So that's why I created one for you. If it is helpful, then I'll be happy. And if you let me know if there is anything that I can improve, or if you need anything, just let me know. I'll try to answer your question. So until then, thank you very much. Thank you for watching, and stay safe.